Hi, I am Meena Sundram. He is my friend Thiyagarajakumar. Today we are going to present the topic Java Technology. That is further proceed by my friend.
Now I am going to speak about Jazelle. First, why Jazelle? Today's world, many of the applications and portable devices and home appliances are enabled with Java technology because Java is a platform independent and it is a portable language. It compiles once and run anywhere. So it is giving good performance. So using this technology in ideal mobile application development also. But what is the problem is getting in Java in portable devices is very difficult and it is very costly and it consumes high power. So we going to Java technology. It is acceleration technique and it gives high performance and it reduces the cost and it reduces the power also. In Java there is two portable bytecode instruction set architecture are having. One is software acceleration and hardware acceleration. First we see about the software acceleration. Software acceleration technique is widely available software solutions for Java execution, but it is not suitable for portable devices and it is not suitable for low cost systems because it consumes high cost and it takes more memory. In this there are two types. One is JVM and JIT. JVM stands for Java Virtual Machine. It is executes the bytecode in hardware by using a Java software platform, and it is also not suitable for mobile applications and developing the portable devices because it incapable of providing inadequate performance. But it have sufficient memory to do the operations. Then we go to the JIT. JIT is a just-in-time compiler. It is dynamic execution, and it is transfers the bytecode into directly existing codes instruction set. So it improves the runtime performance, but it is also not compatible with all portable devices. So the technology was enhanced by the Java technology. Then we see about the Java hardware acceleration techniques. In the hardware acceleration for Java execution is it needs additional space and memory, and it needs external memory also for some applications and portable devices, and it is not maximize the speed. In this hardware acceleration also there is two techniques. One is dedicated Java processor. Another one is Java coprocessor. First we see about the dedicated Java processor. It executes the bytecode in the hardware within the processor, but it was implemented by another processor by using another processing technique. So it will not support all the existing modern OSs and also modern applications techniques. So there is some advantages in the dedicated Java processor. Then we see about the Java coprocessor. It transfers directly a bytecode into a core existing instruction set, and it needs software and hardware platform to run these applications, and it is also not supporting any existing OS. There is a modern OS because it is a traditional technique, and it is also consumes high power and high cost. under poor performance. So we are moving to Jazelle Technology. My brother further going to continue the Jazelle Technology.
Thank you, Shivakumar. Why Jazelle was created means in Java, to overcome these disadvantages, like my friend said that to overcome these advantages, the Jazelle was created for accelerating the process and the additional space to reduce the power consumption and memory consumption. These are the reasons to create the Jazelle. Then the Jazelle technology will complete the hardware and software and provide the solution for these problems. Then it's enable the processor to execute the Java byte code within the processor itself. And then the Jazelle technology provide field features, virtual JVM, that is the Java virtual machine. Using this Jazelle technology, the acceleration, the performance, the speed of the Java is improved up to 8 times then compared to the normal JVM, that is Java virtual machine. Then using the Jazelle technology, the system will be started very quickly. Within the 3 seconds, the system will start up. Then using for accelerating the performance, Jazelle uses 2 techniques. First one is Jazelle DBX, and second one is Jazelle RCT. Jazelle DBX was introduced in the year 2002. That is implemented in ARM v5 architecture. ARM v5 architecture. It will allow the processor to execute the Java byte code within the hardware itself, and it will reduce the startup time, and it will improve the performance of the system, and it reduces the time consuming. These are the DBX in the sense is a direct byte code execution. It will execute the byte code directly within the hardware. Coming to RCT, then ARM tried to implement the Jazelle technology in ARM v6 architecture. It is more try to implement the ARM v6 architecture, but it is more complex. If you implement in the sense, it will reduce the process speed. So to overcome these problems, in the Jazelle RCT was created by the ARM. RCT in the sense runtime compilation target. It allows the AOT compilation. AOT in the sense time compiler. It will occur when the program is compiled, or the program is initialized, or program is downloading, or downloading from the first download from the server. These are the stages the AOT will be occur, and it will also compile the JIT technology. As my friends say that just-in-timer will compile the Java byte code directly into the existing code injection. It is different from the it is based on the thumb EE. Thumb EE is an execution environment which is used in the ARM v6 for Jazelle technology. It is there are many features added in the Jazelle RCT, such as array-based check and null pointer check. These are the main features added in the Jazelle RTC. Then to operate these Jazelle DBX and RCT, they need some software for perform well. For that, the ARM will provide some software, that is JDK and JVM. Then the software the software provide a solution to solve these problems, and innovative technology to improve the performance and features implemented in the J2ME. That is with the product of CDC in the sense CDC and CLDC. CDC in the sense connection device configuration. For example, for these devices are smart TV, PDA, that is personal digital assistant. These are the devices. And CLDC in the sense connected limited device configuration, that is mobile handset, media player. These are the devices using the Jazelle technology. Then ARM will work with the major handset and implement independent software vendor to improve to continuously improve the features of the Jazelle future performance of JDE, that is Java technology enabled gate. Compared to V2 version, that is JDE second version, the third version is twice the performance improve twice compared to the second version. Then the further JDA and JVM will be continued by my friend.
JDE is nothing but, my friend said, Java technology enabled kit. It is a software component which is it can be integrated in existing operating system, that is JVM machines, to integrate the hardware acceleration technique in this component. So we are using the JTEK technique in this method, and the acceleration techniques are transparently known by the Java developers point of view, and there is no modification required in the application code because it already provides high performance and good speed acceleration. So we no need to add any things in this application code. Then coming to the JMVM. JMVM is nothing but a Jazelle mobile virtual machine. This is the product to enhance the Java acceleration in mobile handsets, and it is a multitasking virtual machine. At the time, it processes many number of requests in a single time, and it enables developers to quickly debug the application on product handset, and also it allows network operators and network handset vendors to easily customize the technology by using the Jazelle technology. It is mainly used for the speed of the processor, and ARM announced some new licenses to Java and 3D graphic solutions. The organizations which are licensed by ARM is Pantech, Applex, Innovox, and Oxford Semiconductors, and Samsung and Docomo. This is the some of the organizations which was licensed by the ARM. Then we see about the implementation of Jazelle technology. Implementation is important technique in the Jazelle technology. It is runs within the processor. It no need to add any extra processor to this technique. That is Jazelle implements the low level binary translation. It is mainly used for execute the bytecode into the machine understandable language, then it converted to the human understandable language. So, and it is mainly focused on the application development and good performance. In this, Jazelle was implemented by new only because in earlier ARM and Thumb only used for the acceleration techniques, but Jazelle is implemented for better performance and reduces the cost of the techniques. First, the process of the implementation is first we execute the instruction set and fetch into the processor instruction pipeline. That it executes the bytecode into the Java language, and it decodes by using the Jazelle technology. Jazelle is used for mainly for execution of this processor. Then it reduces the cost of the interpretations, that is executions, and it reduces the JIT compilations, and also it reduces the JVM execution environments also. Then it moves simply that Java Byte Code to hardware. Then the hardware covers subset of the JVM bytecode for handle the unhandled JVM bytecode. that is implemented by hardware invokes the hardware software. Then it is we made here two in-one processor, that is ARM and thumb mode will be act as a implementation process, and the Jazelle is mainly used for execute the process. So we need not to add any extra processor to this technique. This is the main advantage of the Jazelle technology, because it reduces so much of the power and cost of this by using the Jazelle. Then further continue my friend.
Then next topic is ARM ISA. ARM stands for Advanced Risk Machine. Risk in the sense reduced instruction set. Mostly ARM uses 32-bit instruction set. In the ARM in Jazelle technology, to implement Jazelle technology, the ARM instruction set architecture will contain three types of instruction set. First one is ARM instruction set, that is a 32-bit instruction, and the thumb instruction set, that is the thumb instruction set is a 16-bit, and Jazelle instruction that is a 8-bit instruction set. Then ARM has a 32-bit register. The one register is dedicated to PC, and another register is dedicated to CPSR. The CPSR stands for current program status register. It will store the current program. And then 5 register is dedicated to SPSR. SPSR stands for saved program status register, and remaining 30 registers used for general purpose. Then coming to instruction set, this is the instruction set framework of the ARM instruction set. The instruction set is nothing but it is a computer. It is related to computer architecture, that is related to program, and that it include the data types, variables, IO exception, and arithmetic, and etc. These are the things contains the instruction set. This is the frame format of the instruction set. In this 0 to 4th bits are mode bit, that is it's defined the operation processor mode, and 5th bit is T bit, 6th bit is F bit, and 7th bit is I bit. These I and F bits are interrupt disabled bits, and 8 to 23 bits are undefined, that is it's used for future purpose. And 24th bit is J bit, and 27th bit is Q bit, and 28 to 38 these are the conditional flag like N, V, C, V. If the first 4 bit is already say that it specifies the processor mode, whether the processor is sending in the ARM state or thumb state or Jazelle state or thumb state. These are the instructions specified by the mode processor. Then the T bits, 5th bit is the T bit is only it is present in the architecture V5 only. The T bit is set to be 0 in the sense the processor in this ARM state, and T bit is set to 1 means the processor in thumb state. Then coming to interrupt disabled bit, that is I and F. The F bit is said to be 1 means it will disable the FAQ, that is fast interrupt request. Then the 7th bit I is said to be 1 means it will disable the IRQ, that is interrupt request. It will disable the interrupt request. Then coming to J bit, J bit is present in the architecture of V5 TJ, TJ. If the J bit is 1 means the processor will be in Jazelle state. Jazelle mode. Then coming to Q, it will indicate if it is present in the architecture V5. It's also present in the ARM architecture V5. It indicates whether saturation is occurred or not. And then coming to conditional flag, there are 4 conditional flags are N, Z, C, V. The N flag is said to be 1 means the arithmetic operation result will be in negative. Then 0 flag is said to be 1 means the arithmetic operation result will be in 0. And C flag is said to be 1 means the arithmetic operation will be carried out. And V flag is said to means the arithmetic operation will be overflow. Then these thing about the instruction set. Then coming to application binary interface, that is ABI. The Jazz uses the low-level transaction, transaction. So the ABI was used. So for that purpose, the ABI is used. That is application binary interface. It provides a low-level interface between the current program and OS and other applications present in the computer. And it covers the data type of the program, size of the program, and alignment of the. These are the things covered by this ABI, and it will also control. It will perform the call conversion. Call conversion in the sense it will control how the functions and fully perform and how the data will be get from these get from the other function. Then it will control the system call. And there are two types of system calls. First one is direct system call and procedure system call. Direct system call in the sense the function will be called directly, and the procedure system call by using the call will perform by the processor. Then the ABI will provide interface between the JVM and Jazz hardware. That it will use it call conversion between the JVM and Jazz hardware. Then coming to CPSR, CPSR stands for I already say that current program status register. It is used to store the current program. We are writing the program. For example, if we are writing a program in IDE, if the exception is occurred, means then we lost the entire program. To avoid that, say CPSR usually it will store the data automatically. Then the CPSR indicated by combining the 2 bits in the instruction set, that is one is J bit and T bit. In this, the J bit and the T bits are 0, means the processor will be in the ARM state. Then J bit is 0, T bit is 1, means the processor will be in thumb state. Then J bit is 1 and T bit is 0, means the processor in Jazz state. Then both J and T bits are 1, means they are passed in thumb E state. It is thumb W is derived from the Jazz RCD. I already told that. Then here the byte code is decoded by hardware in 2 stages. Then it switches between the hardware and software. While executing the program, it switches between the hardware and software. Then coming to BXJ. BXJ stands for branched Java. It is used to enter the Java state into the Jazz state. It was indicated by J bit. Whether the J bit is 0, the set will be 1, means the BXJ will be executed. Here the condition. These are the conditions. According to this condition, it will execute the Java byte code. Then the Jazz mode will execute by method.
Thank you, my friend. Let's see about the Jazz modes. In this Jazz mode, there are 3 modes in this technique. That is, one is direct execution in hardware, and second one is interpreted in software, and third one is undefined byte code. First, we see about the direct execution in hardware. The most 95% of the byte codes are executed in the hardware only by using the JVM instructions, and it is a common program, and it is also simple program to use this technologies, and it reduces the number of interpreters, and it reduces the number of JIT compilers. It is the main advantage of this Jazz technology. Coming to the interpreter in software. Most of the JVM instructions are not implemented in the hardware because it's automatically generated the byte code into the core existing instruction set. So the startup time will be automatically reduced, and it reduces the complexity of the programming also. And third one is undefined byte code. That is, it handles exception handling, and it throws the exception into the process to handle the error handling, and most of the applications are handled thrown by the exceptions and handled by the Java ARM processor. ARM processor good. It gives best output for the error handling and exception mechanism. Then we see about the architecture of the AML. This is the main part of the Jazz technology. it has so many of methods and invokes into the architecture. That is, here three layers in this architecture. One is application layer, second one is execution layer, third one is processor layer. First, the Jazelle accelerator ARM processor is instruction set. That is a 32-bit instruction set. It provides the runtime environment, and it provides the platform to run the Java applications and other program codes, which was implemented by the Java. Then the Jazelle support code. Jazelle support code nothing but it provides documents and tools and some of the support code for the web applications, and it provides the source of the whole program. Then we want to use JS means we want to buy some license to access the full benefits of the virtual machines. Then only we use the full benefits in the architecture. The Jazelle support code and Jazelle accelerator ARM processors are combined by the JTEK. JTEK is nothing but I already said that Java technology enabled kit. It provides it is a software component. It integrates with the hardware processor, which was accelerating technique. Then coming to the execution part, the memory manager. Memory manager is used to manage the memory in the runtime environment. It allocates the memory space for all the functions which was implemented in the applications. Then the process manager. The process manager is allocates the memory and functions which was sequentially in order to compile and execute the application in this Jazelle technology. Then there was the class loader. Class loader is used for loads the class into the internal memory of the JVM. So we are using the class loader technique in this method. Verifier is used for verifies all the managers and loaders and support codes and tools and documents for this application by the JTEK. And also JTEK provides three available resources, that is Java and QREM, CVM. Java is nothing but a personal Java. It is a original Java code. It's licensed by the Sun Microsystems. QREM is a scaled down virtual machine. It is used for small mobile applications, and it is used for mobile platform that like a media player, handsets. That's all. CVM is a Java compliant virtual machine. It is the latest technology in the in current process. Then it is used for the bigger applications like PDA and some of the setup boxes, and also the PDA stands for personal digital assistants. Then we coming to the application layer. The network is used for sharing the information among all the computers which are enabled in the architecture. Then the graphics is used to develop the application program interface between the user and the system. And remote method is used for invokes the request and response from the processor which was sent from the ARM processor. And also the Jazelle support code provides good performance and efficiency in acceleration technique and some other methods in this architecture. And the native method, it is implemented in any language that was executed by the Java virtual machines. So we are using the native method in the language. Then coming to the Java application, it is a user interface program to implement and execute by the ARM processor. These are the architecture of the VMA. That native application, native OS is already invoked in the ARM processor. It is used for acceleration, and it is default application OS. That's all for the architecture. Coming to the processor, that is ARM V7 TJ. Here in this processor we are using ARM V5 TJ processor. The processor takes all the interfaces which was implemented in the architecture. That is one of the interfaces ETM interface. ETM stands for Embedded Trace Macrocell. It provides data and instruction set and for ARM family, which was integrated with the ARM processor. And mainly the coprocessor interface is used for adding the external coprocessor of the architecture. In this applications, it has so many external components in this processor. And bus interface unit, it sends a signal to all the processor which was started to the ARM, and also it sends signals to the JVM machines also. For instance, it is automatically enable the bytecode to the core existing instruction set. That's all about the process of the ARM V7 TJ. My friend is going to continue.
Coming to application, the Jazelle technology used in wide range of applications like wireless application, and satellite application. There is a connected to the single server. Wireless application sense uses the mobile handset and media player uses the Jazelle technology. For example, Docomo now released a new mobile model that includes the Jazelle technology. Then coming to in laptop cases, the Chrome OS will be uses the Jazelle technology. In home gateway, the home gateway uses the Jazelle technology, and also the in home application like set-top boxes, TV set-top boxes, they uses the Jazelle technology for voice listening purposes. Then coming to home environment in sense email banking, internet services, they uses the Jazelle technology to increase the performance. And there are many real-time applications uses the Jazelle technology. In Mota Vista, company created a new OS that's called Mobile Linux 5.0. It is only based on the Linux. It will it's for mobile. In this OS, they implemented Jazelle technology for increase the acceleration of the Java. Then Artica is a most leading race car company. The Artica GT car, in Artica GT car, they implemented Jazelle technology in dashboard display. In dashboard display, in this graphic controller, in graphics card, they uses the Jazelle technology by using ARM 926 EJ processor and Jazelle technology. Then in Samsung, they developed a new Blu-ray disc player, that is BDP1000. It's enabled the Jazelle technology. Using this, you can play high definition video and high definition TV. Then the BDJ will provide Samsung BDJ will provide Java database. It is a open source database that is given distributed by Apache. Then in few days before, Docomo and Artix company combined and created a new mobile device. The name is Chroma 900. This mobile is only for Indian. It's they introduced Docomo. Artix and Docomo company combined and created a new Java execution environment for improved acceleration. This Java application will be provided is based on the Java ME and CLDC that is distributed by Java committee. Then it started MIDP and INP. MIDP is a subset of Java ME. MIDP in the sense module information device profile. It will control the display like video, text, table. These are the concept control the MIDP. And coming to IMP, IMP is a subset of MIDP. IMP stands for Information Module Profile. It will be used to increase the performance of these application. Then here the document FOMA 90 is implement using ARM 1176J processor for giving the better performance. Then feature is continued by.
Coming to the Jazelle technology, they have so many features and advantages in this technology. Some of the technologies I could share here. It increases the system performance and it provides high efficiency, and the Java Byte Code execution is very compatible to all the Java virtual machines, and it reduces the cost of the components, that is the portable devices and home appliances and many of the devices which was enabled with the Jazelle technology, and it produces consumes the low power only, so we can gain more performance from these applications, and no duplicates of the on-chip memory because it is inbuilt memory using the Jazelle technology, and it's supported for any modern OSs in current existing operating systems also. These are the main features of the Jazelle technology.
Finally, we conclude that Jazelle technology will provide more accuracy for executing Java application, and it will be implemented in mobile devices, and the Jazelle technology, using this Jazelle technology, the system cost will be very low. Thank you.